I think we're privileged here today to have two experts in the water resource reuse program. Jeff Mosier with the Water Environment and Reuse Foundation. That's correct, right, Jeff? Okay. There was some discussion today whether that might have changed or is changing. Jeff is going to help us look historically backwards on how water reuse has kind of been brought to where we are today. And then Dr. David Sedlak from the University of California, Berkeley, is going to give us that forward perspective. When I was asked to moderate this session, I was excited because this issue of water resource has been on my plate for many years. In fact, since 1992, when Public Law 102-575 was passed into law by Congress and signed by the President, that authorized the Bureau of Reclamation to begin what we call the Title 16 program. It's the water reuse program. And when that happened, and I talked to Dan Beard last night about kind of the history of this, how Title 16 came to be, where it evolved, and how it evolved, and we both lamented the fact that what we should have done with that legislation but didn't. But I think the point is that it gives the Bureau of Reclamation the ability to do water resource reuse programs. The Bureau has been, as many of you will probably understand, has not been an agency to embrace water reuse on a big scale. The Bureau is used to building dams, irrigation projects, reservoirs. You give them something that has real concrete and rebar, they're going to do great. But water reuse was not necessarily on their agenda, and they didn't know how to embrace that. I think that's changing, but it's going to take a while. From my perspective, that was one of the reasons I was brought back to work on the Hill by the former administration in 2009. With the stimulus bill, there were 27 water reuse projects that were authorized in the stimulus bill of 2009. We were also asked then, as I was staff director on the Water Resource Subcommittee for the Natural Resources Group, we were asked to look further down the road. How could we use water reuse as an opportunity to expand the water portfolio, especially in the West? Well, on the Hill, we were constantly asked to justify water reuse programs. To many members of Congress, it was hard for them to embrace water reuse because A, the cost per acre foot of water was higher than the traditional federally subsidized projects of dams and irrigation projects. That's still an issue with them today. They do not understand why water costs so much today, or if you're going to develop these projects, why the costs are so high. The second thing they couldn't embrace is that water reuse is usually a local program. It's not an expansive program, and they're used to regional water development programs for river basins, et cetera. So, and to them, it's an unsustainable source of water. So we're still fighting that battle on the Hill, but it's one that I think we're slowly making progress on. A little bit of history in regards to water and national water policy. In 1965, the Water Resources Planning Act was passed by Congress. And this allowed for the establishment in 1968 of a National Water Commission. If you want to look back to when we last had a national review of water policy in the United States, you got to reach back to 65, essentially, because out of that process came the National the Water Council, which did a lot of things in respect to helping to consolidate how the federal government viewed itself in terms of national water policy. When you think about it today, we have 26, I'll make that 27, federal agencies that have water in their mission statements. I think it's fair to say most of them do not talk to each other. The best is the USGS in terms of managing the distribution of data. The final commission report in 1973 had 17 chapters and 232 recommendations. 3 or 4 of them were specifically related to water reuse and expanding the water portfolio for the United States. The Congress has not enacted any comprehensive review of federal water resource management since then. I think it's high time that they do that. In closing, I believe it's important to recognize the role that the National Academy of Sciences plays in national water policy, because without having the science as the basis for how we make decisions, we are hamstringing ourselves. I have had the luxury of spending time on several sides of this water discussion. For over 30 years, I was with the federal agency, the Bureau of Reclamation and the Department of Interior, where we dealt with trying to implement public policy in terms of building dams and reservoirs, managing rivers, etc. For 14 years, I had my own private consulting firm, where I dealt with water issues around the country and around the world related to water policy. And then from 2009 through 2014, I was on the Hill, looking at developing national water policy for Congress. So I've been able to see this from several different angles. And I think if there's one consistent factor in all of that, it's that science has to be the key to that information and how we interpret that science. We are faced today with significant water challenges. The traditional approaches into developing and managing water require review and revision. Whether you're looking at it from the principles and guidelines, whether you're looking at it from the perspective of waters of the United States, whether you're looking at it in the direction that our federal agencies are taking on water, I think it's critical that the National Academy of Sciences and the Water Science and Technology Board have a place at that table, because you do provide an opportunity to ensure that the science is integrated. So our two speakers today are going to focus on, as I mentioned, a look backwards and a look forwards. And then from that perspective, we would like to invite you all, if you have questions, to put them forth. And if you don't have questions, I got questions. So we're going to start with Jeff Mosier. He's going to give us that perspective to look backward. Please welcome Jeff Mosier to the stage.
Well, thank you so much for the opportunity to be here. And I think one of the reasons I've been asked was because I've been involved in implementing some of the information through reports that have come out of the National Academy of Science in terms of reuse. And I think I'm going to relay that to you today in terms of what that is. Certainly, we've been able to enjoy the ability for these resources to look at the science, and they have translated not just into national policy, but down onto how projects are permitted and implemented and how regulations are developed. So I should mention that David Sedlak and I are tag teaming. We partner on a lot of issues related to reuse. And just one thing about Water, Environment, and Reuse Foundation is that we're merging with another research foundation called the Water Research Foundation. So we're going to have a slightly different name, the Water Research Foundation. It's going to take place January 1st, so I will be part of a new organization then. So one of the things I wanted to emphasize in terms of this talk was the status of potable reuse in the U.S., looking back a little bit, but also the benefit of these water reuse reports that have come out of the National Academy of Sciences. We've supported them as an industry financially, and I think we've benefited from the results of these, and I'll go through a little bit of that. And then really this idea of how science has been used to inform policy, and that's particularly true with reuse, because there has been gaps in the science, there have been information that we've needed in order to develop regulations and implement projects. So I just want to go over just briefly what we're talking about in terms of potable reuse. We have indirect potable reuse that we utilize an environmental buffer. So it can be a groundwater basin, and there's two ways to get the water in the basin. You can do it through wells called injection, or spreading through basins, which also involves natural treatment, soil aquifer treatment. There's also surface water augmentation. I don't have a slide on that. That's another form of indirect potable reuse. And then what we're talking about a lot today is moving towards direct potable reuse, where we avoid the environmental buffer, and we either go directly to a surface water treatment plant or directly into a water distribution system. So there's a lot of questions associated with this, and I have a couple slides at the end specifically on direct potable reuse. But I want to step back in time a little bit and talk about where the National Academy of Sciences supported this area. So back in 1982, and I really didn't know about this report that much until recently when I was looking this up, there was a report that was commissioned by Congress to study the use of wastewater contaminated Potomac estuary. Today we'd use impacted or some other word rather than contaminated as a new source for the District of Columbia. It didn't go through, but basically they were going to use a reservoir, an estuary that had wastewater discharged into it, and they wanted to know if that could be done safely. So it focused on water quality criteria. This was actually the toxicology board. It wasn't WSTB. And so the findings were very relevant today, the importance of the treatment reliability. You'll hear that word a lot. the need for confirmatory data, we call that monitoring or compliance data or performance data, but a lot of monitoring of parameters, and the limitations on detecting trace organic chemicals at the time. So what was going on in the potable reuse world? Well, there were specific projects that I call case by case that were trying to solve specific issues. So in California, they call it water supply, but they didn't have to build a pipeline to discharge to the ocean. There's reasons why it was more practical for them to spread it, but that's the longest serving project. Is still operational today. Water Factory 21 in California, that was saltwater intrusion barrier to protect the basin from seawater intrusion. That project has evolved to the groundwater replenishment system in 2008. The Upper Occoquan Service Authority, they have reservoir augmentation here in Northern California. The idea was to improve the water quality of the reservoir because they wanted to continue to discharge wastewater to the reservoir. So you can kind of see the pattern here that there was a real need to do these projects other than water supply. And in Denver, they had a diversion project that EPA awarded them to take water from the western part of the state, but they required them to examine alternatives for future water supply. So that was sort of the lay of the land in '82. So here are just a few pictures of Montebello Forebay. It's still in place. It's in a very urbanized area. Water Factory 21, it was torn down in 2007 to make room for the groundwater replenishment system. And the Upper Occoquan Service Authority is, that's their facility here, discharging to the Occoquan River. So I do want to take just a minute and talk about the role of non-potable reuse, because we were able to become comfortable with potable reuse based on our experience with non-potable. So we're using wastewater for other things besides discharge. It required a change in thinking. It was meeting customer demands. There was additional treatment that was needed. We worried about the reliability more, and we had different water quality requirements. But what we found out through a lot of work there is that it wasn't a panacea. There were high costs. You had a dual distribution system, maybe storage during wet months, and it wasn't a huge increase in water supply. So non-potable is a valuable when it can be done, but it didn't solve all the issues for us that we're trying to address through water reuse. So in 1998, things were changing. There was more reason for the National Academy of Science to revisit this. A lot of our best water sources were already developed in terms of groundwater and surface water. We had more technologies that were coming on, advanced oxidation membranes. There were public health studies with current projects, particularly EPI studies in Los Angeles. And there was an increasing interest by communities and utilities in pursuing potable reuse. So the study was supported by a range of interested parties. EPA was the largest contributor, but we talked about the USBR's interest, the research foundations, as well as utilities. So in 1998, there was a different landscape. We had more projects. El Paso had a project that was groundwater injection. West Basin, which is in South LA, they had an injection project. Gwinnett County had a surface water augmentation, Lake Lanier. Scottsdale had a groundwater recharge project versus injection. And the primary reason was mainly water supply. So you can kind of see now that the idea was use this as a resource for water supply, not just to solve a water quality or discharge issue. So in 1998, the report covered a range of topics that are very relevant: chemical, microbial contaminants, assessing health risks, which was very useful for having a science body do that for the industry, understanding the health effects, and then looking at this idea of reliability and quality assurance. However, as most of you may know, there was one sentence that's very well known that's been a prolonged discussion within the industry, and it was this: that the community views the planned use of reclaimed water to augment potable water supplies as solution of last resort. So it resonated. We still talk about it today. We talk about it that maybe it set us back, but I actually think in many ways it made us sharpen our pencils and think about this more and realize that, yes, this is provocative and we need to do it the right way. So I think there's a lot of good that came out of that statement, but it did last with us and was a lot of part of our conversations. So in 2012, there was another report published. This was looking at water use in general, but potable use was a big part of it. And the landscape was changing even more. There was a dramatic increase in interest in reuse, particularly potable reuse. We had 4 states that were doing a lot of reuse. Water scarcity was becoming a driver. However, there were also several projects that failed during this time. say they were proposed within a community, and due to issues, whether they're political or social, maybe the projects just weren't good enough, but they failed. And that got our attention. And we knew that we just couldn't do these projects. We had to figure out how to make them acceptable to the public and really understand them, that they solved issues. The Water Use Association went national. The Water Use Foundation received a grant from the USBR. We used to call them earmarks. We can't talk about those anymore. We don't have that. It would be nice if we could get some federal funding for these type of research efforts. The NRC was interested in understanding the role of reuse and how it could play, what it would play in the nation's water future. And the study supporters were a lot of the same ones, but you also see folks like CDC show up, National Science Foundation, and you can see the interest was broadening. Okay, so in terms of projects, things were becoming bigger and more widespread. So the Water Replenishment District, which again is in Southern California, they had saltwater intrusion barrier as an application, but they're really interested in the water for water supply. Inland Empire Utility Agency, where Rich Atwater spent a long time as GM, they have a groundwater spreading project. The groundwater replenishment system took the place of Water Factory 21. Right now, it's the largest facility of its kind in the world. It's expanding to 130 million gallons a day, which is about 30% of the water supply in Orange County, California. We're seeing there's a project in Colorado, which involves natural riverbank filtration, again, for water supply. So the 2012 report was important in a number of different areas. One, we were really hoping we could get past this idea of the option of last resort. And we think we did. The committee came out with language that drinking water augmentation could increase the nation's total available water supply. That was very useful for us. I use this type of slide in many talks that I give around the country on reuse. It also addresses the idea of de facto potable reuse. It goes on, the report acknowledged it, and this really helps us with public acceptance, that they understand that our waters aren't as pristine as we tend to think they are. So it also addressed a lot of science questions, treatment monitoring operations, treatment options exist, monitoring operational plans are needed. I really felt that the discussion on risk was very helpful. There's methods to assess risk. An occurrence of a contaminant doesn't necessarily mean that there's a significant risk. It's useful for a science body to be able to say things like that. So now there are a number of planned projects, so we see the concept growing. The Metropolitan Water District of Southern California, which is solely a drinking water agency, is thinking about reuse. They're planning to build the largest reuse IPR facility in the world, 160 MGD. Hampton Road Sanitation District here in Virginia, the driver's a little bit different. They're going to get nutrients out of the bay, mitigate subsidence, address groundwater overdrafting. There are a lot of benefits associated with that type of project. That's the way it'll probably look like in places like Virginia. El Paso Water is thinking about a DPR system. This would be a system without a surface water treatment plant. They're moving forward, and they're along with design on that. Altamont Springs has a DPR demonstration in Florida. Reno's in Nevada. Other states you wouldn't think of per se, they adopted regulations 2016 and they have a project planned. So just a couple words on direct potable reuse. Utilities see a large advantages to going to reuse. There's increases their flexibility. If you don't have a groundwater basin or surface water reservoir, it's not needed. You're still able to do it. And it's part of an integrated water approach. And that's where we're going in terms of thinking about our water resources, is doing it more integrated water way. And DPR and IPR fit into this. We do have a DPR facility in Big Spring, Texas. It's the only operational one in the United States. Wichita Falls was emergency supply. Again, it was DPR. It operated for 1 year. In California, the State Water Board was asked to look at this. They had an expert panel answer the question whether it was possible to develop regulations for DPR. They said yes. David Sedlak served on that panel. It was a great success in terms of the issues that they covered. And there's lots of other states that are interested in regulations: Arizona, Florida, Colorado, to name three. And I just want to put this slide up in terms of where the interest is going. The ones that are in the darker color, the yellow, those are current permitted projects. The other projects are planned projects or proposed projects in California. You can really see the interest that IPR and DPR has in these places that are particularly water scarce. So in terms of DPR, we do have key questions, treatment requirements, monitoring requirements, The technologies, are they reliable, understanding their performance, source control, keeping constituents out of the collection system. Operators and operations comes up as a big issue for regulators. They want to know it's operated correctly, response time, and public acceptance. So I'll just finish up with a quick summary. So polar reuse is expanding. Utilities and research foundations are conducting a lot of studies and research. IPR is very viable, but DPR is going to occur. State regulators have played a critical and positive role here. And the NRC water reuse reports have played an important role in helping to advance polar reuse. The use of experts, science-based, verified a lot of the concepts and approaches, supported regulations and permitting, and have really identified important areas for us to study. So Dave, I'll stop there and turn it back over to you.
Thanks, Jeff. I appreciate those. That look down memory lane in respect to water reuse, et cetera. I think it's fair to say that water reuse is becoming much more important to local water suppliers as they look at the diminishing, especially in the West, supply of available surface water. They've got to find a way to expand the water portfolio to meet the public's needs. And I know from my time on the Hill, it was every day. Somebody was coming in saying, we want to expand our water supply. We don't have the expertise or the ability to do that. Help us out. Often that was in the form of legislation. So I think what I see, and one more comment about the slide on California. If you look at that slide and you look at where all those projects are, they're all basically south of the Bay Delta area, the area that's most impacted recently by the drought conditions and are seeing a huge need for expanding that water portfolio. So I think that's a perfect segue. And the second half of our tag team, Dr. David Sedlak from the University of California at Berkeley, is going to look forward with us and get a perspective on where we're going to see the water reuse programs going in the future. David?
Thank you, David. Thank you, Jeff, for giving us such a nice background to things. So I'm very happy to be here and to join the Water Science and Technology Board. And this morning I sat in on the meeting and I saw a lot of water scientists. I saw an economist. I saw a few people who were bored. But I didn't see a lot of technologists with a capital T, and I think that maybe there are a couple of us there thinking about this issue of technology, but I think technology is really important for a couple of reasons. One is that when a scientist or an engineer invents a device, it's a technology, and that technology diffuses. And so it takes an amount of time, and then it comes into commonplace practice. But also, when new technologies are invented, they create new industries and technologies that kind of jumpstart off of that existing technology that's been invented. And finally, those new technologies sometimes teach us a way to see the world in a different way. So consider your iPhone for a moment. 10 years ago, it was invented. In a period of a few years, it diffused to a point where it was in just about everyone's pocket. As that device diffused, it created new industries, things like mobile navigation, mobile medical help, and also things like social media. And then when we had those social media, we started seeing the world in a different way. We've seen that our perception of reality isn't exactly what we thought because those media, that social media is amenable to manipulation by people. What I want to do is I want to talk to you about water reuse as a technology, and I want to talk about the diffusion of that technology, picking up on where Jeff started off. I wanted to talk about, in the future, how it's going to spawn new industries or new ways of delivering people with water. And I also want to talk about how water reuse is changing our perception about all aspects of drinking water. So I want to start here with this technology diffusion S-curve. It's the kind of thing you might learn in business school or in an economics class. And it tells you that when a technology is invented, it moves quickly from its first invention and pilot plant through a demonstration, and at that point there are innovators working with it. And then there are the early adopters, the progressive people who have a need to use the technology, and they develop the experience. And once that technology clears that initial threshold of demonstrating that it works and having a group of early adopters go through the hard part, it diffuses quickly. And I think Jeff told you about some of the projects that diffused out into the world and how now we're moving into this period of the second generation when new technologies are being new water reuse technologies are being used. Let me give you an example. This figure comes from data in the 2012 NRC report, where you can see the axis here is scaled to kind of meet our charge as a panel. So our charge was to ask, how much could water reuse increase the nation's water supply portfolio? And what we did is we said, let's consider all the wastewater now that's discharged to the ocean. That's the full potential of water reuse, because inland discharges are possibly used by downstream communities or by ecosystems. And that gets us to about 12,000 million gallons a day. Sorry about the engineering units, but this is how wastewater engineers think, not in terms of cubic meters, or for the hydrologists out there, acre feet. And if you think about it a little more seriously, you realize that there are parts of the country where water reuse probably isn't going to be very interesting. Parts that have enough water already, like Boston or New York or Seattle, where water reuse for potable purposes is probably far off into our future. So let's say only about half of the country needs that water reuse. Now let's compare it with the projects that Jeff talked about. They're shown here in the red dots. And so we're only at a few % of our potential for satisfying the needs of water-stressed cities. And then I put that green asterisk there because that's the total water reuse, including water reuse for landscape irrigation and agriculture and applications that are not seen as potable water reuse. So we have a long way to go. Now, since the 2012 report, as Jeff told you, we've had a variety of new projects. In fact, the capacity of potable water reuse has increased by something about 80% since the 2012 report. So the technology is moving quickly, and as Jeff gave you that impression, we're diffusing quickly, and kind of you get this idea that the train has left the station. But if you think about it a little bit harder, you'd say, well, we're only at 5 or 10% of our total capacity. What's holding us back? And so with that in mind, the NSF Engineering Research Center, Renew It, with a program in which I'm the deputy director, joined with the US EPA and sponsored a workshop at the Johnson Foundation at Wingspread in Racine, Wisconsin on October 27th to 29th this year. The red dots here are not the locations of water reuse projects. That's where all the participants came from. So we tried to get a diverse cross-section of people around the country, and we asked this question, we posed it in this way: how do we overcome the institutional barriers to potable water reuse? Because if we're not moving out and filling that need and the technology is not following the traditional S-curve, maybe there's a problem. It's not a technological problem. You can see that projects like the groundwater replenishment project in Orange County are doing just fine, thank you. There's not a big question anymore about the technology. Perhaps it's the institutions that are holding us back. And after a day and a half of discussions, we changed the title of the workshop because we came to learn that it's not really a question of institutional barriers. It's a question of leveling the playing field. Because water reuse is a technology that's ready for prime time. And what we see happening now is that it has to undergo this process of mainstreaming where engineers and water supply planners look at it as a viable technology that they can use to expand a region's water supply portfolio. And it has to kind of come into be seen on the same footing as other water supply options. And so when I think about the NRC's role in the future of potable water reuse, I feel like organizations like WENRF or WRF or whatever it's called now, Jeff, are doing just fine, thank you, because there's an industry that's taking this technology and moving it out, and there aren't the same sorts of large overarching questions. And even the DPR question is being handled by groups like the California Expert Panel or some of the expert panels that have been convened around the country. So in terms of the first question of diffusing, it took the iPhone 5 or 6 years. It took potable water reuse 30 or 40 years, but it's on its way. What are the new industries, though, looking forward that are going to be spawned by water reuse? I think the real issue is how we scale it down. So a lot of cities that have built potable water reuse systems right now are big cities with big treatment plants, 100 million gallons a day of water serving the needs of 1 million people, and they have a lot of expertise. They have full-time staff members who can dedicate themselves to water reuse projects. In some cases, they have sophisticated laboratories and PhDs on staff. But not everyone lives in a city where you have a water treatment plant, a wastewater treatment plant that serves 1 million people. And so a lot of cities are looking at what's going on in potable water reuse and saying, well, what about us too? And it's not just cities thinking about it, it's people like real estate developers and architects who are looking at this and saying, maybe this is the way in which I create a new water supply in a water-stressed area where I don't have access. And so one of the overarching questions now as this new industry starts to develop is it really different? Is it the same and only smaller, or are there differences? And when I think about the differences between a large centralized treatment plant and a small scale treatment plant, I'll tell you in a moment what I mean by scale. One difference is you don't have the expert operators on site. The other is the monitoring. You can't do the same kind of sophisticated monitoring at the same frequency. There are going to be permitting challenges because each one of these centralized plants now is a whole project to permit. And then you have this other issue of the flow of the water. There's going to be variable flow and quality, whereas the city, you're averaging water from 1 million people, and the water quality seems quite a lot more uniform. So let's think about it as a continuum of scale. Let's think about an axis here, a logarithmic axis going from 1 person to 1 million people. And what we're building now are centralized treatment plants that serve close to 1 million people and have this level of sophistication. Now, there are some challenges here of having some cities that have large centralized treatment plants that lack the institutional capacity to do this because they may not have the right finances, they might not have the right kind of institutional culture, but we think that that is something that can be addressed. It's these smaller places where this new industry might be created. If we think about decentralized treatment plants working on the scale of like 10,000 to 100,000 people, you run into some of these same issues of like not having someone who can be a full-time water reuse person and go to all the conferences and keep up with the literature because they're trying to keep the plant running. But this seems to be something that we're capable of doing. For example, the Big Spring plant was served about 20,000 people. And so you can have a utility that uses the same types of technologies, microfiltration and reverse osmosis, that are used at the big centralized plants, and you can build up the institutional capacity. So that seems to be one that's going to happen anyway in some of these smaller cities. We could think about another smaller scale on the order of several hundred to several thousand, and I would call this district scale or neighborhood scale treatment. Imagine, for example, that you're building a greenfields housing development and you're a real estate developer and you don't have a water supply, and your option is to run a pipe from a distant location to supply you with water, or find a way to use the small amount of local groundwater and rainfall that hits your development and supplement it with water reuse. Potable water reuse could be part of this. You may not just be limited just to gray water and toilet flushing. This is a figure on the inset from a project that the Charles River Watershed Association wrote about non-potable water reuse at the district scale within Boston. But there are starting to be cities like in San Francisco that are thinking about potable water reuse at the neighborhood or district scale within their city to augment the water supply. And some of that has to go to the fact that once you can break the tie to the centralized water supply, it's more than just a water conservation project. It obviates the need to have a centralized drinking water system distributing water to your neighborhood. And that can have tremendous economic savings. And finally, we can think about the building scale. There are architects and developers thinking about the idea that you can do potable reuse at the building scale. And sometimes, like here, this photo of the Bullitt Center in Seattle, you might do this because it's an ultra-green building and you want to demonstrate what you can do to people. But other times you might be in a rural community where the water supply from the local groundwater or rainwater isn't enough for you. And you couldn't live there if there weren't a water supply. So it's a choice between direct potable reuse and bringing in tanker trucks full of water. And if you don't believe that this is something that we're going to see in the future, and I hadn't really thought much about it until a few years ago, look at this project that was recently permitted and built in Ohio. It's a building scale DPR project that the Tangent Company built, and it passed through the review of the Ohio public health regulators. It was a small land trust, you can see the building there, that was in a location with a tight aquifer that didn't supply a lot of drinking water. And so what they did was they took their septic leach field, essentially, and turned it into a direct potable reuse system. And they conducted a research project and showed that the reverse osmosis and advanced oxidation processes that they were using at the building scale were just as effective as those used at the centralized scale. And so this opens up a new industry and a new way of providing water to people. So that's the diffusion of the technology and the possibility that new industries are going to be created by this technology. Let's turn to the third issue of perceiving of our drinking water differently. Let's think about something that I'll call here the technology continuum. Now, I'm going to try to I forced myself in making these slides to think about the perceived efficacy of treatment plants from low to high. So I don't want to imply that any of the treatment plants I'm going to show you do not provide safe drinking water, because they are all actual treatment plants that provide safe drinking water. But some, I think the engineers and water scientists here would agree, are safer than others because they provide more barriers and more safeguards against possible deviations in water quality. So let's start here with the full advanced or FAT treatment. This is the kind of treatment train that's used in Orange County in the groundwater replenishment project. And in many of the DPR projects that are being built now, they use this as the core, and they add some more technologies on top of it to assure water quality. So there are probably a half a dozen projects like this that use reverse osmosis followed by UV light and hydrogen peroxide, or an advanced oxidation process, before putting water into the drinking water supply. And I think if you talk to engineers, they would say this is the gold standard, full advanced treatment. It's probably the highest efficacy of a treatment system because it's usually accompanied by lots of other things like industrial source control and continuous monitoring that assure high quality water and multiple barriers for pathogens and chemical contaminants. Now let's look at managed aquifer recharge. Jeff already mentioned the LA County spreading basins and the Aurora project at Prairie Waters. There's also a project in Orlando, Florida, sometimes called the RIBS project, Rapid Infiltration Basin. I put these circles here to show you the relative size. So about enough water for 1 million people is that blue circle on the side there. And you can see these are big projects that have been running for quite a while. And I would say that they're pretty darn good. We've been doing this since 1962 and know a lot about the LA County project. We'd probably never build another project like the Whittier Narrows project. If we built projects in the future, they'd probably look like the Prairie Waters project in Aurora, Colorado, where we use riverbank filtration. We pump that water out and put it in what I would term an artificial aquifer for some enhanced soil aquifer treatment. And then we send that water to an advanced treatment plant with an advanced oxidation process, GAC, DAC, and chlorination. So we also use advanced drinking water treatment on this water after it's been through. And that water coming down the South Platte River is essentially pure wastewater effluent from the city of Denver. So I would put this as almost as good as the full advanced treatment of Orange County, but it doesn't have the reverse osmosis membranes that were essential in Orange County that provide a lot of the health protection barrier that engineers feel is so good. The third one I'd put in here are these surface water augmentation projects. Jeff already talked about Gwinnett County, the Upper Occoquan project as well in Virginia. These are projects where you basically use the best possible wastewater treatment plant, like an advanced wastewater treatment plant, and then you put the water in a reservoir and it spends time in the reservoir, and then you treat it again when it comes out of the reservoir. So this is what the Upper Occoquan project looks like in terms of technology. You can see in brown there all of the wastewater treatment technology. So those are not your grandmother's wastewater treatment plant. You have line clarification, multimedia filtration, GAC and BAC, ion exchange and breakpoint chlorination when needed, followed by a final chlorination. The water goes into the reservoir, and then the drinking water treatment plants have ozone and GAC. So you can see lots of barriers. My concern here is that surface water reservoir is probably not as good as a groundwater aquifer because you have more hydraulic short circuiting, you have shorter residence times, and you have the potential for pathogens to make it from the wastewater into the drinking water supply that probably don't exist in the same way in a soil aquifer treatment system. So I would put it just below the managed aquifer recharge system. And finally, the last one, the last category, is kind of on this continuum of de facto reuse that Jeff mentioned. And I'll just mention 3 projects here. the Santa Ana River, where the wastewater from the Inland Empire goes down to Orange County, and Orange County takes it out of the river and percolates it into the ground, and it becomes the groundwater of Anaheim. The Trinity River in Texas, where the wastewater of Dallas and Fort Worth end up in the reservoir for Houston and becomes a significant fraction of Houston's water supply, as well as Dallas-Fort Worth's water supply. And then a project in Clayton County where engineered treatment wetlands are used to treat wastewater before pumping it into a reservoir. And these projects maybe are exemplified best by this project near Dallas, the North Fork project, where basically wastewater from the effluent-dominated Trinity River, so at this point the Trinity River is essentially pure wastewater effluent, it passes through some constructed wetlands. You can see them here, these surface flow wetlands, and then after passing through the wetlands, it gets pumped into the local reservoirs and becomes a drinking water supply. Now, I've studied wetlands for a number of years. They're generally pretty good at removing nitrate during the summertime, but they don't really do a very good job removing viruses, and they don't do a very good job removing trace organic contaminants. And that's been a concern of mine for many years, and in fact, it's, so I'd put it here, sorry. So in fact, it's been a research topic of mine, and one of the things that I've done through our Renew It Research Center is worked on developing new kinds of treatment wetlands that could more effectively inactivate viruses and remove trace organic contaminants with wetland systems. And you can see an aerial photo of the one we built in Orange County on the Santa Ana River. And I've been so excited about this project. I've been working on it with my graduate students and publishing papers. And I said, this would be a great project for them to replace those surface water wetlands that exist in Dallas and Fort Worth that I think are not giving them good water quality improvement. And so we made a trip to Dallas, Fort Worth. We met with some of the folks down there, and we said to them, this would be a really good thing to do. And they said, you know, you're right. It's probably a better treatment technology, but we can't convince our board to spend money on this. And besides, we're already in compliance with the Safe Drinking Water Act. So why would we do anything beyond the Safe Drinking Water Act? And that put me face to face with an issue that I think is equivalent to the way we re-examine the way we see news now. I would call this the Big Discontinuity. The Safe Drinking Water Act was designed to regulate a system of drinking water that really the last technological improvements were early in the 20th century. So it's really biological wastewater treatment, followed by filtration, sand filtration, or mixed media filtration, followed by dilution in the environment, followed by disinfection, chlorine, ozone, UV, and that's it. That Safe Drinking Water Act regulates that practice and provides us with safe drinking water. And potable water reuse, in contrast, takes a variety of different treatment technologies, and I'm not going to read them all here. You can see them all listed, but it also includes enhanced source water protection. It includes enhanced monitoring, both public health monitoring and chemical contaminant monitoring, and it includes like an institutional framework that more closely examines the water supply. And when you confront people in the drinking water field with this big discontinuity, you get one of two different responses. What you hear from the drinking water people, the Safe Drinking Water Act people, is that those crazy people doing potable water reuse are totally overdoing it. We can deliver safe water just fine and not spend all of that money, and we're very comfortable with the Safe Drinking Water Act. And then on the potable water reuse side, you hear people saying, I can't believe that people are drinking secondary effluent out of the Trinity River using just a surface water treatment plant. And I'm doing these backflips trying to do reverse osmosis and an advanced oxidation process, spending millions of dollars in labs and special studies. I feel like I'm providing better water. And so, you know, I think it's a question, the kind of thing that the NRC could opine on, of which one of these two things we should be doing. Because if the answer is the Safe Drinking Water Act, maybe we're overdoing it with potable water reuse, and after a few years of experience, we'll ratchet down the degree of public health protection. But the other answer to that question might mean that the Safe Drinking Water Act needs to up its game in order to protect public health. Well, you could guess based on my history and pedigree where I come down on the side of saying that maybe the Safe Drinking Water Act needs to be re-examined. And let me give you 3 examples of where I think the Safe Drinking Water Act is failing us now. 24 years ago, the largest public health outbreak in the United States happened, the Cryptosporidium outbreak in Milwaukee. It was detected because the city ran out of Pepto-Bismol. We've done some things since then to assure that maybe Milwaukee doesn't happen again, but I would think that we could do a little bit better than what we've done by putting a Band-Aid on the Safe Drinking Water Act with the idea that we could prevent that from happening again. I don't think in the kinds of potable water reuse projects I work on that we would ever see this kind of public health outbreak and it would go undetected. There are just too many multiple barriers. There's too much scrutiny of the process. I wouldn't be surprised if another crypto outbreak or something equivalent like Legionella, well, it's already happening, were to happen again. West Virginia, 3 years ago, a water supply goes out of business for a couple of weeks because a spill happens upstream of the distribution system and gets carried into the distribution system and contaminates it. That just is not going to happen with a potable reuse project. There's online monitoring, which if we had a departure in water quality, would send the water somewhere else and wouldn't send it into the distribution system. This is kind of embarrassing when this stuff happens. And finally, happening right now, millions of Americans' water supply being tainted by perfluorochemicals or PFAS, which are being used in military and civilian airports as well as in consumer products. And you know, when you wake up in the morning and you hear that 15 million people are drinking water with concentrations of a toxic chemical that's causing health effects, and it's not being regulated because the CCL process is broken and is unable to add new chemicals to the regulated chemical list, you feel a little sad. And Americans seem to be recognizing this. So this is the result of a survey by AP and GfK that came out in February 2016, which came out with the distressing answer that only about a third of Americans drink water out of their tap without any filtration. Another third use a filter of some kind, and the other third use bottled water. I think if we think that the safe drinking water is being effective, we are in the minority here relative to the public. And if we want to build public trust and confidence in the water supply, as well as protecting public health, I think maybe this idea of re-examining the Safe Drinking Water Act is something that's spawned by the rethink of drinking water that comes from potable water reuse. So some questions of national importance that we might want to ponder. In the technological side, how can the latest technologies be applied to more effectively detect chemical contaminants and waterborne pathogens, both in terms of public health monitoring, like sentinel monitoring, and developing an understanding of unknown contaminants before they turn out to be problems? How can we better assess effects at the community level? I've been to meetings at CDC. It's really hard to figure out if contaminants in drinking water are causing public health threats. But with things like the exposome and emerging technologies from the biosciences, we may be able to see these kinds of effects in communities. What types of drinking water technologies can offer improved public health protection? Maybe membranes shouldn't just be used at water recycling plants. Maybe they should be used more frequently at surface water treatment plants that are subject to upstream contamination. And what role should managed natural systems play in water quality improvement? Right now, with managed aquifer recharge, we throw it in the ground and hope it works. Likewise with wetlands, if it's pretty and it has birds, we could do a lot better there in terms of technology. And then institutional issues, I think that this whole issue of sources of contamination, it's more than just what comes out of the sewer. We use our sewers as an industrial dumping ground for chemicals from commercial industries. And that often is the source of contaminants, things like the PFAS compounds. They're not coming exclusively from consumer products. They're coming from industries that aren't sufficiently regulated. And the GAO has written about this in the past, but we don't do anything about it. What are the roles of new business models in the provision of safe drinking water? Maybe in the future, it's companies providing point of use and point of entry treatment systems. Maybe it's real estate developers and homeowners associations or private companies that do the potable water reuse. And then how do we best assess public health threats? And beyond just risk assessment, how do we think holistically about critical control points and also how we might anticipate these rather than responding to failures in our water system?